Let's talk about all these materials today. I printed out a PLA, and you can see right away. Alright, level 1 is PLA. It prints perfectly on everything. It stands for polylactic acid. It captures good detail, it's good for rapid prototyping, but it's brittle and it'll literally melt in any hot environment or any hot car. It's very weak. Here's a prototype I printed out of PLA, and you can see right away, it takes nothing to give these parts out. That's why we switch over to PETG. PETG, it has more flex, it won't warp in the sun, and it handles moisture a lot better. If you need a functional bracket or something around the house, PETG is the way to go. And it is usually considered food safe. This is a part that I printed out of PETG. You can see that this will not give. This is a feeder for a reptile. Level 2 is where we started to get into carbon fiber PLA and glass filled PLA. Now, these are mainly for aesthetic. They don't add anything to the strength properties. They make the filament more brittle, and you do need a hardened steel nozzle for these because they're very abrasive. But here is a part that I printed out of carbon fiber PLA. It is very smooth. And here's a part that I printed out of glass filled PLA. This is a charging stand for my phone and my earbuds, but they're not much better than regular PLA. Now here's level 3, which is TPU. If you don't want a rigid part and you need the flexibility, vibration dampening, and impact resistance, these can make custom gaskets and do everything that you need flexible. Here's a phone case. This is very flexible. It holds its shape. This is a custom bracket that I made for Cyberdeck. Also very flexible. Everything about it. And here's actually one in function. These are for my earbuds. This is an earbud case, which is made out of TPU as well. Very flexible to keep my earbuds safe if I ever drop them. Now, you may have seen my other videos with TPU where I've made custom gaskets for motorcycles. I've made float bowl gaskets. I've made carburetor gaskets. This is very good. It is gas resistant, heat resistant, but it does have its limits. So don't push the limits and you should be fine. This is ABS, and this is what more than 50% of the parts on your car are made out of. Car bumpers, many things in the engine bay. It has great impact resistance, great heat resistance. This is one part that is made out of ABS that is in cars. It is injection molded. Now, it doesn't have the best UV resistance, so you can't let these parts sit in the sun because they'll end up yellowing or cracking. And that's why we have ASA. It is the exact same thing as ABS, but with all the strength for sun. It has all the strength properties, all the heat properties. It is pretty much the exact same thing, but when you leave this part out in the sun, it will not crack or not yellow. Level 5 is straight engineering grade filaments. This is polycarbonate, aka PC. It is a great material that has a lot of strength properties and heat properties. This is a part that I make out of polycarbonate, which is a BMW E30 headlight intake. It has a LED light inside of it because this material actually reflects light very good. It is a great material if you need something that can take a heavy hit and heat as well. It's not the best to heat, but it can take definitely a lot more heat than other materials. Now, while polycarbonate is a brute force material, nylon is actually very good for friction. It has low friction properties. It is still very impact resistant. It is still very good strength material. And if you need a custom gear or a moving mechanical part, nylon will almost outlast anything else than what you would think of. It is very moisture prone though, so it can suck up a lot of moisture. It needs to be thoroughly dried out like most materials before printing. Now, level 6 brings us to my favorite material, which is carbon fiber nylon, and this is carbon fiber nylon 612. There's a lot of different ones. There's a nylon 12 carbon fiber and 6 carbon fiber. This is a mix between both nylon 612, and it's a very, very good material. Unlike carbon fiber PLA, it's not just for aesthetics. This is extremely tough, extremely resistant to heat, and it makes it incredibly stiff and lightweight, whatever part you're printing. This is what mechanical engineers use to replace metal parts every day in manufacturing. This is my favorite material. I use it for a lot of things. Now, there is a level 7 for ultra polymers like PEEK and Ultim. PEEK is polyether ether ketone. Ultim is just PI. Now, these materials are very expensive. They require very expensive machines, and they would literally melt the insides of a printer like this. Most times, all you'll need is stuff like nylon carbon fiber, PC, and other things like that. Peak and Ultim are very impressive materials. They're used in aerospace, dental, things that need very high heat resistance and structural support. If you actually look into these materials, you'll be very surprised on where they're being used every single day in our lives already. Now, let me know in the comments what material you use most for 3D printing. I love sharing knowledge about additive manufacturing, and I'd love to hear your thoughts. If you want to learn more, leave a follow, save this video for later so you can come back to it and remember exactly what material you should be using for whatever application it may be.